Good afternoon. It's my pleasure to welcome Blok to the stage to talk about peeking into TLS with Wireshark. So, take it on.
Yeah. Let's see, let's put it to mirroring. It is mirroring. First challenge succeeded. Speaking of challenges, who's doing the CTF? Yeah. There's one challenge for me, and if you pay attention in this talk, you get a little help in solving it, so maybe that should keep you awake for now. After lunch is always a difficult spot, but I'm going to do my best to entertain you and marvel you in the wonderful worlds of SSL decryption, or TLS decryption. I still say SSL once in a while, so I hope I'll change that. But, just for me to get to know you a little bit better, do you use TLS decryption? How many people already do? And did you ever do it in Wireshark? Just a couple of hands. Do you use private keys? Yeah. Session keys also, a little less hands, but okay. For you, I think this is not so new, but there were not that many hands, so maybe for the rest it is new. Yeah, and a lot of people come to me like, I'm trying to do decryption and it doesn't work. Can you help me? And for me, it's like if you know how things work, then you can understand why it doesn't work if it doesn't work. So I'm going to try to teach you how SSL decryption actually is supposed to work and why it works, and then we're going to see how we can do it ourselves. And also, I want to make sure that you can select the right tools to do decryption. Well, a little bit about me. I call myself a relational therapist for computer systems, as I analyze data traffic between systems to solve problems. I've been a member of the core team of Wireshark since 2007, and going to SharkFest every year to present and help people on ask.wireshark.org. So if you ever have a question, you can post it there, and me or somebody else will answer it. I started my own company in 2010, providing troubleshooting and training services. So that's a little bit why I'm here. So first of all, if you look at this statement from vendor X in this case, I want you to think about it for a second and think, is this something I can't tell? Is it something that I'm sure that it's not possible? Or is it something that you think is possible? And if you scan the QR code or go to menti.com and type in the code 428970, I'm curious to see what the audience thinks of this statement. Let's see, I don't see anything coming in yet. Is the QR code easier, or it's not working at all, maybe? Did somebody try? Yeah. Oh, there we go. 4. Let's see. Don't be afraid. You can also answer, I would have to guess. So, well, let's not stick to this. Like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. Okay, let's thank you for joining. Let's see what the results are. Where's my mouse button? Oh, there it is. Show results. So a lot of people would say, no, this is not possible. And a couple I would have to guess, which is very honest, because I think that's a reasonable answer. And quite a few people, also 5, say it is possible. So let's see why it's possible or not possible. Let's close this one. Okay, thank you for participating. So let's go back to here. So my goals for today is understand how TLS decryption works, using the server's private key and also using TLS session keys. And I want you to be able to evaluate products that offer TLS decryption after this, mainly because SuriCata doesn't do any SSL decryption itself. So it relies on other products for that. So it's good to know how to evaluate the tools that you might want to put in your network. And of course, since I'm a Wireshark guy, I want you to be able to do the TLS decryption in Wireshark as well. So those are the goals, and I hope I will succeed in that. So why do we use TLS and certificates? It's for confidentiality, of course, and of integrity, but also authentication, a part that some people sometimes forget. And let's see how we can do that. And it is a very short refresher on how TLS works, but that's needed to understand why decryption works. So if you have two systems that want to communicate, we can create a symmetric key to do encryption, because symmetric encryption is CPU not too intensive. So we create a symmetric key, we share it, and we can, of course, through a secure channel, but then we can encrypt traffic with a symmetric key, which is all fine. Confidentiality is fine, integrity is fine, authentication is fine, but there's a problem, because the keys need to be unique. So if you have multiple customers, like on a website or something, then this won't work, because you need a distribution method to exchange unique keys. So this is a start. So we can use a symmetric key, but we need something to exchange it with. So the method that can be used is asymmetric key, of asymmetric encryption, in which case you have a public and a private key pair, and something that you encrypt with one of them you can decrypt with the other, but not with the same keys. So if I have a public key, I can send it to the client, and it's public, so there's no problem there. And then if the client creates a symmetric key, it encrypts it and it sends back to the server. That's pretty good. We have confidentiality, we have integrity, we have a way of distributing a key. But how to prevent the man in the middle? If you put someone in between, he can impersonate the server, and if you have no way of checking that, then there's no authentication, and so this won't work either. So the next step is, let's create a certificate authority, or a third party that proves or is able to prove the identity of a key and of a server. So the server maintainers, they create an identity and a public key to use for the encryption of the session key. They register it at the CA, and it's been signed by the CA with its private key, and then you get a certificate. That means if I have the public key of the CA, I can verify the validity of the certificate, and I can use the public key to encrypt the session key, and then everything is fine and nobody can look into the traffic. So if we take so much trouble to encrypt stuff, why should we want to decrypt it? Well, there's a couple of reasons. By the way, this is the bomb machine. This is the machine that cracked the Enigma. If you have ever a weekend off or want to spend time at Bletchley Park, I can really recommend it. It's a really nice exhibition, and they have a computer history museum there as well, so it's good to go there. So for me, in my area of work, it's mostly because of application performance monitoring and also troubleshooting. But in the security area, it's of course for malware and virus detection, data loss detection and prevention, and also forensics. So there is a need to decrypt. So why can we decrypt? How does that work? If you have an RSA key exchange, which used to be normal until actually quite a while ago now, but if you have an RSA key exchange, you can do decryption based on the private key, and that works as follows. The client, in setting up a session, it creates a random value, it sends it to the server. Server creates a random value, sends it to the client, and then there's the certificate with the public key, and then something magical happens, that the client creates the pre-master secret, which is the material that the keys will be based on. It encrypts it with a public key, sends it to the other side, and it can then start to generate the keys for this session and move over to the encrypted phase. And then the server uses its private key to decrypt the encrypted pre-master secret. And then it can do the same thing, create a session key, and then you can exchange data. So if you mimic that process, if you're capturing on the wire, and you capture the client random, you capture the server random, and you have the client key exchange in which the encrypted pre-master secret is being transferred, then you can use the private key of the server to decrypt that message and have the keying material to create a session key. And then you can do decryption. So in short, if the session key is transported over the wire encrypted with the public key from the certificate. So that means with the private key, you can decrypt it and get the session key. In Wireshark, you need to start capturing before the browser opens if you're using a browser to test, because with TLS session resumption, you need to have the initial TLS handshake. So provide the right server key in PKCS1 format, or in PKCS12 format if you have that, and then you can use password if needed. Or recently there is some support for net HSMs. I haven't used that myself, but I know it's there. I don't know which net ASMs we support, but there was one case. I've got a link in here. I think the slides will be provided, so the link in here if you want to try it yourself. I've made a little case on CloudShark that you can use. So there's a recipe to do that. So this is the case with a public, an RC key exchange. Well, in a visual, there's a pcap, you transport the private key, you configure the key in Wireshark in the TLS protocol settings, and there you go, you see that there's TLS and the decrypted HTTP in Wireshark. If I don't run out of time, I can demo that at the end of the presentation. But how do we get the private key? You should not be able to get it. Like unless you're the server administrator or it's a test environment, you should not be able to get the private key. At least I hope you're not be able to get it. HSM cards which store the key on the card, that won't work. Some NetSM HSM device, they will work. But you need to protect the private key with your life, because that's the crown jewel of your server. So do you really want to do decryption on your laptop and have the private key on your laptop and have it lingering around, and maybe your laptop gets stolen and yeah, you don't want it on your laptop. So we come to that later in a minute. This works well for incoming sessions for which you have the private key, but what happens when you're going to a server on the internet but you don't have the private key for? The only way to do that at the moment is, or one way of doing that is to be an active part in the SSL session. So you terminate the TCP session, you open up a new TCP session to the backend server. There you do TLS, and then you create a certificate for that server based on your own CA certificate. And then the client gets a TLS session to your device with signed by your own CA. So that works perfectly for outgoing sessions or incoming if you don't have the key, but the client needs to install the root CA of your firewall or your man-in-the-middle device. So that could be a problem. And certificate pinning will fail, so sites that use certificate pinning, that won't work anymore, because obviously you create a new certificate, so you are the man in the middle. And also mutual TLS, where you do authentication, doesn't work, because that needs to be end-to-end. So you can only authenticate to the endpoint of your TLS session. So it has some drawbacks. Well, there's the next gen word again. There are a lot of man-in-the-middle solutions. These are a couple of them, like some firewall vendors, they provide these solutions. Some application delivery controllers can, of course, do decryption and re-encryption. And there are some applications, either for your laptop or for in the network, that can do it as well. And one of them that I use often is man-in-the-middle proxy, which is really easy to set up. Yeah, you need to install a certificate on your device, but if you want to analyze a mobile application, that's the perfect way to do that. But now we have a problem. Like if we look at the internet today, almost 80% of all sessions are not using an RC key exchange. So the most sessions will be using Diffie-Hellman ephemeral Diffie-Hellman to create the session keys. And that's to provide perfect forwarding secrecy, to prevent people from making a trace now, getting the key later when the key might not be valid anymore, but they find the key and then they can decrypt the traffic from years ago if they captured and kept that. So Most sites use Diffie-Hellman exchange these days, ephemeral Diffie-Hellman to negotiate the keys. And then the previous examples of decryption don't work anymore. Also, TLS 1.3, after 28 versions and 5 years of working, has been finalized last year, and TLS 1.3 skips RSA key exchanges. There's no ciphers anymore, no support for ciphers that do RSA key exchanges. So moving from TLS 1.2 to the TLS 1.3, which is occurring at the moment, means decryption based on private keys won't work anymore. So you need a new solution. And let's have a look at what the difference is between an RSA key exchange and a Diffie-Hellman key negotiation. So the start is the same. You create a client random, you create a server random, and then something different happens. The server creates an ephemeral, so a temporary key pair of public and private key. It sends its public key to the client. Then the client does the same. It creates also a temporary key pair with a public key and a private key. It sends its public key to the server. And then the client uses the client's private key and the server public key to create a pre-master secret. And then the master secret is created and then the session key is created. So now the client has a session key. It can turn into the encrypted phase of the connection. And the server does the same with the Diffie-Hellman protocol. If you do it like this, you create the same key. So the server uses the public key from the client, its own private key. It creates a pre-master secret. Then, together with the server random and the client random, it creates the master secret, and from that, the session key is extracted. This actually is a little oversimplification because there's a little more to it, but for understanding what you need to do decryption, this is sufficient. Then the server can go to the encrypted phase and you can exchange data. The same goes for TLS 1.3. It's a little simpler because they reduced the amount of round trip times. So instead of sending the key first, the client creates keying material at the start, creates the random, it sends the random and the keying material straight away to the server. The server does the same. And then there's the same pattern in creating the session keys and going to the encrypted phase. So why doesn't encryption work on the private key here anymore? Because there's no exchange encrypted with the public key. Instead, all the exchanges are done with data that's been in the memory of one of the endpoints. So how can we do decryption in this situation? Well, you do get to capture the client random, so that's fine. You do get to capture the server random, so that's fine. And the pre-master secret, you can't calculate it because it's based on the private keys and they're temporary. So what you need is to have one of the endpoints, either the client or the server, present you the session keys. So the master secret that it created from its own private key and the public key from the other side. If you have that session key or the master secret, you can then calculate, the pre-master secret. You can then calculate the master secret and from that the keys, and again you can do decryption. So the whole challenge now is to get to those session keys. One sidetrack to how do you do this in Wireshark. Again, start capturing before opening the browser. Use the SSL keylog file environment variable with Chrome and Firefox or with curl, recent versions of curl. Then you can log the session keys on the client. And if you point Wireshark to the file with the pre-master secrets, then the decryption works as it did with the private key. So again, there's an exercise that you can do yourself if you go to the download site or to CloudShark after this. So basically, in the graph, you're capturing traffic, you're relying on one of the endpoints, in this case it's the client, to provide you the TLS session keys. You configure it in the TLS protocol preferences, and there you go, you have your decryption again. Actually, this is from the other example, but it would be the same image. What? previous slide. Yes? I believe the question is, where do you configure the pre-master secret log file? This is in Wireshark, yes. That comes from your log file that you created. So if you open Chrome or Firefox with an environment variable of SSL keylog file, and you point it to a file, and then that's the same file that you point Wireshark to. If all goes well, there will be time for a demo at the end. I'm not sure how far I'm time-wise. Oh, pretty much. I need to hurry up. Okay, I can go on. So how do you get these session keys? There's a couple of options. There's applications using NSS like Chrome and Firefox. You can set the SSL keylog file variable. There's OpenSSL applications. If you use OpenSSL with a version 1.1.1 or later, then you can also log to a file. But you need to do it in your application. You need to add support yourself. Curl can do it. OpenSSL S client has always been locking the master key. If you open with OpenSSL S client, if you open a connection, the master key will be locked, and you can put it into Wireshark. Java applications, there's a library that you can use to add to your application, and then it will lock the keys. Of course, some the load balancers can do it. The Microsoft TLS library and the Apple TLS library, they don't support it yet, so hopefully that will be coming in the future. Because, yeah, once TLS 1.3 is there, we really need it. Then, doing some research for this presentation, there is also possibilities to steal the TLS session keys. What do I mean by stealing? Is if you have control over the host, you can get them from memory. So you can extract them from memory. And there's actually a couple of tools that do that in an efficient way. And also there's a tool, Telescope and TLS CACs, that can extract them from VM memory. So if you're on the hypervisor, you can get them from the VM memory from your VMs. So that's another way of getting keys. And there's actually, recently there's a product that's been contacting me, or a vendor that's been contacting me, that they have a solution like this, and so that it's getting there also for tooling. So it's not only some executable, some project somewhere, but it's actually being deployed in or being vendor. So what do you need in Wireshark to be able to do this? You need to set a couple of preferences, and oh, that's a little quick. Good news is that these settings are all default settings. So if you use the default profile, then you will be able to do decryption. If something doesn't work, please check the settings for fragmentation, reassembly, and checksum validation. They need to be like, some need to be on, some need to be off. So you need to check that. Then if you have TLS session resumption, so if you have an initial TLS session and other TLS sessions will use the same keying material, you can do the decryption, but you will need to have the initial session in your capture file. So always make sure when you do a test that you start your capture before you start your engine that's going to connect to the server. So if you use a browser, close your browser, start Wireshark, and then open your browser to go to the test site. Because otherwise you don't have a key exchange, and then you won't have the decryption. Then with mutual TLS, some people ask me if you have like mutual TLS where you also authenticate the client with you ask a client certificate, will decryption work? In that case, yes, it will, because the process of verifying the identity of the client does not include any of the keying material. The key in the private key in the certificate will only be used to authenticate. So decryption is not affected, so you can use that. So how can you check if decryption works? Because sometimes you don't see any application layer traffic, and that might be caused by higher layer protocol dissection failures. But if you want to check if the decryption was successful, filter on TLS handshake, and then check whether the encrypted handshake messages after the change cipher spec. If they change to finish, then you know that your decryption worked. So that's a good check to make sure that that part of your troubleshooting is actually working. If you do decryption with a TLS private key, the private key, you don't want to send that private key to another third party, and you do want to offer decryption, then you can export the TLS session keys from Wireshark. So you do the decryption with a private key and then export TLS session keys, which means you get a file that looks a little bit like this, or exactly like this. And that's the file format. But you get a file with the keys, and you can provide that to your third party to do the decryption. If you don't want to put it in a separate file, since I don't know when, I think it's like a couple of months ago, or maybe half a year ago, there is support for embedding the TLS session keys inside a pcap ng file, so inside your pcap file. That you can do that with editcap. It's a command line utility that's being provided with Wireshark. And if you do editcap -- inject secrets, TLS, and then the file name of your session keys, the source file, and then the destination file. The destination file will have the TLS session keys, so you need to only provide that file to the other side, and recent versions of Wireshark are able to decrypt the TLS sessions inside that capture file. And one little trick, if you have like a large file with session keys and you don't want to provide all of them, with this little grep you can extract the session keys that are specific for your capture file and then put those in your capture file. So it's a little trick that I use. So in short, decryption with private keys is fading away. So in a couple of years you won't be able to do that anymore because we move on to TLS 1.3. And only decryption with TLS session keys will be possible. So you need to retrieve those keys from applications and their TLS libraries, or from memory extraction, or from VM memory extraction, and then use those in your tooling. So you need to challenge your tool vendors. You need to ask them, do you already have possibilities to do decryption based on TLS session keys? And if they do, how do they get their keys? Ask them where they get them from, because not every server or client is able to provide them. So I think the vendors need to be challenged into providing support for TLS decryption based on session keys. And with Wireshark, as you have been seeing, you can use either method. So now that we've done this, let's go back to the Mentimeter, because I'm curious whether this has changed your view on. So go to the last question and see whether we have a changed pattern in the responses. If so, I've done my work well. If not, then I should talk again, I guess. So let's wait a couple of minutes or a couple of seconds. There we go. Did anybody change their mind after this presentation? Just by hands already? Yeah, good. Then something happened. Good. Well, let's look at the results. There we go. Now everybody says it's possible, and it is. But of course, the answer is always it depends, because it depends on whether you are able to get to the session keys. So that's very hopeful that the message did come across. Thank you for participating in the test. And I don't know, I think I should quit. Kelly, is there time for a little demo, or should I quit? Quick demo? Yeah, we love demos. Oh, okay, good. And then we go to the questions and answers. Okay, if there are any questions. So let's do a little. I've got Wireshark here, and I've got a trace file that uses an RSA key exchange, because I only see the client key exchange, no server key exchange, so I know it's a RSA key exchange. And if I load the certificate, so I go to Protocol Preferences, RSA key list, and then I press where I need to add a key, and that key file, I select the private key, which is in this file. You used to need to fill in the IP address of the server and the port and the protocol. That's not necessary anymore. Just fill in the key and you're done. And if I click on my button to select the HTTP traffic, you can see that there's now HTTP traffic in the trace that's been transported over TLS. So this is a basic example of, and if I go back to the TLS handshakes, you can see that all the handshakes are ending with a finished message, so that proves that all the sessions are indeed decrypted. So this is the example with the public key. So let's open the example with the session keys. So that's this session. So I have an encrypted session here, encrypted handshake message. So it's not decrypted yet. If I look at HTTP, there's no HTTP in the trace. And if I now go to, oh, not there, go to the protocol preferences and then enter the pre-master secret log file name, then you browse here and you go to the keys for this specific file. And then you see that now the session ending finished and there's HTTP requests in the trace file. So the files that I used, like TLS, Diffie-Hellman keys. So this is the entry in the keys file for the TLS session-based decryption, and of course the TLS RSA PAM. That's a private key. You can take a picture. It's a test server, so I don't care if you have the private key. Normally you wouldn't do this on. Please be careful with your private keys, but in this case it's okay. Let's do one more demo on how to use Chrome to do decryption of your own traffic. So I put in some commands because I don't want to type everything in. So I'm creating a new TLS session keys command, and let's now point my Wireshark to that. So go back to TLS security, and now I need to do the TLS session key. So that's a new file, no keys yet. And if I then export the keylog file and then start Chrome with this environment variable, and now I go to Rabobank, for instance. It should work already, but let's quit. I didn't start a capture. You need to start a capture. Let's quit Chrome. Thank you for pointing me in the right direction. It's always fun doing demos. There we go. There we have some traffic. Let's add something to the filter. Because I'm not interested in HTTP traffic. I'm only interested in encrypted traffic. And now start Chrome again. And stuff should be happening already, but let's see what happens. Rabo. There we go. Site can be reached, of course not, because you need to type correctly. And there's my session. Let's log in with pcap or something. 1, 2, 3, 4, 5, 6, 7, 8. Card number. Well, you get the message across. This is it is TLS encrypted. If I do a filter on host equals to, and there we go. We have the page that was just retrieved over TLS. It's been decrypted by your session keys. So that's basically. We're running out of time. So, is there any question about this? No questions? Well, then I hope everything was clear. And I've provided some links in the presentation for you to look at as well. And I want to thank you for your attention. And if you have any questions later on, feel free to email me about it. So, thank you.